Now we would like to look at an example, and we see whether the function is holomorphic or it's not. Okay, so we have example 2, and we have our function f of z given as okay, we said we have the real part and the imaginary part. Okay, I'd like to give it as 2y plus ix. Okay, so of course we know that z in general is written as x plus iy. Okay, so we said that df of z with respect to dz is going to be equal to the limit as delta z approaches 0 of f of z plus delta z minus f of z, and then we divide everything by delta z. So what do we have here? We are going to have limit as delta z approaches 0. So we have f of z, so f of z plus delta z is going to be 2y plus delta y, okay, then plus I into x plus delta x. Okay, then minus then f of z, which is 2y, and then minus ix, and then everything is divided by change in z. Of course, if that is z, then change in z is simply that the change in z is given by the change in x plus the change in y. Okay, so what do we have here? We have limit as delta z approaches 0. Some terms are going to cancel, like this 2y will cancel with that, and then ix will cancel with this. So we have 2 delta y plus I delta x. We divide by delta x plus I delta y. Now for this one here, we can try out, it's quite pretty straightforward. We can try out different directions. For instance, we can, for our complex number, remember we have the real part of z, and then we have the imaginary part of z. So we can say that, let us approach, maybe if this is our complex number z, we can say that let us approach, that complex number along in a direction which is parallel to the real axis. Okay, in other words, if it is parallel to the real axis, we are saying that delta y, that will imply that our change in y is 0. Okay, so we have that our change in y in that case is going to be 0, and then of course our change in x, okay, it is x because this is the real, and then this is the imaginary. Okay, so we are saying that it's like x, which is varying, but our y is not varying here. So in that case, we write limit as delta z approaches 0. Okay, we'll be precise. We'll say as delta y. Okay, is it delta? No. Okay, how do we write this? What's the best way for me to write this? Okay, we will write limit as delta x approaches 0, since we have said that we are moving along in a direction which is parallel to the x-axis, or the real axis, in other words. So as delta x approaches 0, of course this is 0. Okay, this is going to run to 0. So no, sorry about that. What we have is that as delta x approaches 0, we know, we have said that our delta y here is 0. There's no change in y since we are moving in a direction which is horizontal, okay, either way. So our change in y is 0, so that is this term will run to 0, and we are left with I delta x, and then we also see, or we have said, this term goes to 0, and then this is divided by delta x. So, and this is going to be limit as delta x approaches 0 of I, okay, and simply which is going to be I. So let us see what if we are trying to approach this z in a direction which is parallel to the vertical axis. In this case, our change in x is 0, and it is only y which is varied because we are moving in any direction, a direction which is parallel to the imaginary axis here. So for that matter, if we are moving, then we would have to write and then say okay, I'll put a comment here and then say this was in a direction which is parallel to real of z. Okay, so now what about if we move in a direction which is parallel to imaginary part of z? So we would say that the limit as delta y approaches 0, okay, we have the same of 2 delta y plus I delta x divided by delta x plus I delta y. So in this case, remember we have said if we are considering that our change in x is 0, so this disappears and this disappears. So what we are left with is what we have here is limit as delta y approaches 0 of 2 delta y over I delta y, okay, which is going to be limit as delta y approaches 0 of 2 over I, okay, which is going to be 2 over I, and then we know we always have to rationalize this, and then which is going to be 2I over I squared, which is going to be negative 2I. Okay, so the fact that as we approach z in a direction which is parallel to the vertical axis, we get a limit 2I, and then if we approach z in another direction, we have now our limit as I. The limits are different, okay, so remember we said that if the limit exists, then it is unique, and in all directions. So if that is z, whatever direction we are approaching z from, okay, the limit has to be the same. So here we have found that when we approach z in a direction which is parallel to the x-axis, we have a different limit from when we approach z in a direction which is parallel to the y-axis, or in other words the imaginary part. Okay, so we are going to conclude, and then we say that therefore our function f of z, which they gave to us as 2y plus ix, okay, we say that is not, okay, holomorphic. It is not holomorphic, okay. Yes, so that is for an example of one which is not holomorphic. You can try to look for many others, and yeah, you can try to work them out. Okay, so see you in the next session.